Today, what we're going to be referencing is an excellent machine learning library in Python called scikit-learn. I use this almost on a daily basis when I'm working in Python. It's fantastic for just about everything in the world you ever need for machine learning and certainly for data science. So that's what we're going to be referencing using just a few of the actual functions that are already included in scikit-learn. We'll be doing most of our work right out of a Jupyter Notebook used in the Anaconda environment, in our own virtual environment inside of Anaconda. So I've got Jupyter already fired up and ready to go. I won't dive into the super deep details of a lot of this stuff. My intention is to keep this for beginners and keep it at a very high level, so I want to keep it very simple. So if someone's coming along and they're learning how to do this, they can literally look at what I have on the screen without diving super deep into the details of it and at least replicate the same accuracy that I have at the end of this. That's sort of my intent here. I will go through and explain a little bit of this as I'm going through, though, just to get you up to date on kind of what's happening here. So since I'm working with a simple CSV file, I love to work with a separate library called pandas, and I've already brought that in to the environment itself, installed in the environment. Now I've brought it in to my workspace in Jupyter Notebook, and pandas is an excellent library for working with multiple types of data, from text all the way to CSV files. Almost anything out there, pandas will actually work with. And one of the reasons I like pandas so much is because I originally started sort of my machine learning type world when I got into data science was really centered around R. And R, sort of the base data structure for R, as we all know, is a data frame. Well, come to find out, it's basically the exact same thing in pandas. So I import pandas with a handy reference of PD. So if you're a new person and you're wondering kind of what this nomenclature means, instead of typing pandas down the road, if I want to use anything that's included in the pandas library, all I have to do is type PD, and then I have access to all the functionality of pandas. I'm also going to be using NumPy just a little bit. NumPy is an excellent numerical library for Python. Won't be using it extensively here, but anytime I'm going to use it, I'll just call it as NP. Here I'm importing scikit-learn itself. This is probably actually a little bit of overkill because I've got these other things, but I'm also importing two different classifiers from scikit-learn. The first is a neural network, which is a multi-layer perceptron. The second is k-nearest neighbor. Both of these are coming in as their own functions, one called a k-neighbors classifier, one called MLP classifier, and I'll have to assign variables to those later to sort of instantiate those when I use those. Now, let's talk just a little bit about how I use, or how we use, scikit-learn. The hard part of scikit-learn is not actually using it. The hard part is the reference. For most newbies, and especially if you're new to Python as well, understanding sort of how to sift through the absolute Greekness, difficulty, ancient Greekness of this reference is paramount to your success. And I'll give you an example, right? Say I want to go and I want to do some classification. Well, if I'm new to machine learning, look at all this terminology that's here, right? If I'm brand new to machine learning, 9 times out of 10, I don't even know what a lot of this stuff means. So my point is, the reference itself is built for someone that really already knows a lot about machine learning, right? So what I would do, if you're a new person trying to sort of learn this type of stuff, is stick with the high level things that you know. Watch some of my earlier videos, read some of my earlier blog posts, especially the day 0 and day 1 introductions to machine learning. I'll link those in the introduction section of the video for you on YouTube, so you can get an idea what I'm talking about. But stay high level, right? Don't dive into this super duper technical stuff. Look for things like classification. Look for things like you probably have read what an SVM is, right? You probably understand or have at least heard of what KNN is, k nearest neighbor, right? These are two two very common algorithms. So diving into that, things get a little dicey. So let's just say I want to read about nearest neighbors. Well, this is written really from a programming standpoint, not really from a lot of avenues of machine learning. So it's best to set up your own environment. Use Anaconda if you're starting. If you don't want to use Anaconda, if you're on a Mac or something like that, you already have Python installed. Definitely research, creating your own sort of small virtual environment so you can keep your instances separate from each other, and build your own working Python environment. Build your own data science or machine learning environment. Come in and copy and paste a lot of this stuff. Obviously, the arrows don't go with it, but copy and paste a lot of this stuff and try your best to make it not work. What I always tell most of my students is the hard part of learning anything new in programming is not the semantics of the language. That stuff is very strict. But what differs all the time is actually the feedback that you get from your interface or from your integrated development environment, right? So if I make a mistake in some of this information, maybe I leave out a quote here, right, for this particular one, that doesn't tell me that it can't find the iris.csv file that says EOL while scanning string literal. I don't know what that is if I've never done this before and I haven't done any type of programming. So do your best to go through this stuff and try to break it while you're using it. And that's the best way to learn kind of, what the typical errors mean, and you can trace that back to kind of where you might have made a mistake. So anyway, that's the hard part about scikit-learn. So I'm going to go ahead and run the first two cells in Jupyter Notebook so we can at least see what the data looks like. Now, if you've seen the previous videos, you know what this looks like using summary inside of RStudio. We're doing the exact same thing here. The only difference is I'm looking at I'm looking at the first 5 rows of the iris data set. I also want to dive in to sort of the data types. Now if I want to go in and actually do something with EDA, I can do that here if I'd like, because I already have this in a nice data frame. Sorry. There we go. Oops. That doesn't help if I spell it wrong, does it? So if I want to actually get some type of descriptive statistics like I do with summary in R and RStudio, I can do that here. I'm not necessarily doing that. I've already done EDA on this in a separate exercise. So all I'm doing here is just verifying that the data came through as needed. And that's just giving me a small sample. That's why I don't want to see the entire thing. The next thing I want to do, just like I've done in R and RStudio, is I want to check the data types to make sure they came across as they needed. So we've got 4 floats here. Float is just a numeric data type that generally has decimals in it. The species came across as an object. So in R and RStudio, what you have to do is generally convert species from a character over to a nominal data type, which is called a factor, right? Well, that's already coming in as an object here. What I have to actually do is convert this to a category. Some people do this and some people don't. Some people will encode their data directly from this standpoint. Bottom line is we have to encode this, right? Setosa and Versicolor and Virginica, all these words that come in, Python can't do anything, or scikit-learn can't do anything with that. Those things have to be changed over to representational numbers. So all I'm going to do is just overwrite the actual column species and just change its type to a category here. And now I've run this again. You see I've got category, and then I can just use cat codes and take a look at the data now, and species is full of numbers now, right? So each individual type of iris flower now has a representational number assigned to it, and that's exactly what we want to do. So we're getting close to the end, believe it or not. Now all we have to do is actually slice the data frame. So in order to do that, and by the way, we're doing that with pandas and just the numeric indices of the columns. So we're not actually calling the columns by name. That's what this format means here. It means take all of the rows and all of the columns from 0 to 4 and assign those to the variable x, and then print out the first 5 of those. So since I want the independent variables to be these 4, right, the first 4 columns, that's what I'm doing, and I'm assigning them to the variable x. Well, all that's left over is the 5th column, and that's what I want to be assigned to the variable y. Now, something I'm not doing in this video that I did in the other one is I'm not doing any type of cross-validation here, right? I'm not going to that length here. All I'm doing is going to go straight in to model building. I'm not even going to do predictions. I'm just stopping short of doing any of that because I don't want to get super deep into scikit-learn. I will build another video on a much more complex data set where we are using cross-validation. We're actually breaking the data into x-test, or x-train, y-train, y-test, and ground truth. So we'll do all that in another video, but I don't want to actually overwhelm anyone here. So the last 2 things we're actually going to do is actually build models. Now in the previous video in R, I built a model with KNN with Caret, and I built a model using MLP with Caret. So I'm going to do the exact same thing here. And all I'm doing, you can see how simple this is, I'm calling this k-nearest neighbors classifier that I actually brought in here. So I imported that entire class, right? And now I'm actually I'm using KNN as a reference point for this function, for this algorithm. So now anytime I use the letters K and N, I'm actually passing this K and N classifier to it. Notice I'm not passing any type, or I'm not defining or passing any type of hyperparameters here. I'm going to let scikit-learn try to figure that out on its own just to keep things simple. If I wanted to specify what K and N, the number of Ks, I can put it right here though easily as anything else. So the next thing I want to do is just fit this model, right? Just like we did with Caret and train in the previous video. I just want to fit the model to it. That's all I want to do, is fit the algorithm to it to build this model. Typically, you just have KNN.fit and then x comma y. I've got np.ravel, and this is where NumPy is actually coming in. This is, you can see, this is just a single column vector here, and scikit-learn wants it in a slightly different format. So I've got this np.ravel in here. I can show you what happens. You don't really get a problem, so to speak, if you take this out and I run it. But you see, I get this warning, so to speak. This is not necessarily a bad thing, but for the case of making this video, I want it to be error free. So just know that that's what that means. It's asking you to please change the shape to something a little bit different for Y. So I've done that with NumPy. So I'm just building the model here. That's the point. And then the last thing I want to do, every model in scikit-learn has this default function called score, right? So now that I've built a model and it's called KNN, I can actually see what the score is for that model. And in this case, default score for KNN K-neighbors classifier is accuracy. And I'm just setting this equal to a new variable called score. So when I do print it out, it comes out in this nice this nice format here. If I didn't have that, I can show you. It comes out much different, right? So it comes out like that, and that's not very easy to understand for the video. So it's just rounded off. That's all. So around 97%, which is almost spot on what we got in the R video, which is kind of cool. So let's do the same exact thing. You'll see the nomenclature is almost identical for this, and this is why building these type of pipelines is super fast. So I'm going to do the same thing again here, but this time with MLP classifier, I'm actually going to pass the maximum iterations up to about 1500. And I'll show you why in just a minute. I don't necessarily have to put anything here. Matter of fact, I'll take it out just so you can see what the warning is. Same thing I did as above, MLP fit. I'm passing my independent variables and my dependent variable. I'm creating the score from MLP score for my X and my Y, and I'm rounding that off. Now when I run this, you can see what it's telling me is the maximum iterations have been reached. The default iterations, because this is a neural network, the default iterations are set to 200. And what that means is the neural network hasn't had time to actually converge yet, which means it hasn't really had time to optimize. So what I'm going to do is go in here and actually increase the maximum iterations to 1500. The error goes away. I didn't get any change in accuracy whatsoever, but if this was a more complex data set, I may very well could. I mean, you want to let a neural network go till it converges. So anyway, my accuracy here on MLP is around 98%, which is a little bit better than what it was using R. And the discrepancy here is probably going to be that the training data, when I built the R video, I used cross-validation, so it had a little bit less training data to use. So that's probably why I got a higher accuracy here, because I had a little bit more training data to work with. But anyway, within the percent or two, you can see they're almost identical, which is great. So anyhow, making predictions from this point is super easy. It's basically just like what you've done already. If you watch the previous video with R&R Studio, there is a predict function here, and you can literally work the same way. You're passing your trained models to a test set. You're applying it to a test set, building predictions, and then figuring out whatever your assessment metric needs to be for your overall assessment. Generally you can do accuracy or kappa for classification, or sensitivity, specificity. You can do ROC scores in the case of problems that generally are binary. Maybe you're doing something with logistic regression and a classification problem. So I know that sounds funny, but those two things do go together. Or maybe using R squared or RMSE or even MSE if you're doing something with predictions. So anyhow, that is the second piece of this video. Same identical data set as we've been working with the entire time. I promised you one that we would build in Python with scikit-learn. I think our next video probably is going to start over from scratch and get a lot more detailed in data. We've been using this Iris data set for about 4 or 5 videos now. I'd really like to get a mega, data set for us in here to work with, and who knows, maybe we'll get something big enough to actually shift away from sort of our own machines here, and maybe we'll do something with Spark and Databricks or something like that. So I think that would be really cool to kind of go to next, but maybe that's too far, too fast. So let me know in the comments what you think, and I'm happy to take some suggestions, and always want your feedback as well. So please don't hesitate to leave it for us. Thanks so much for watching this today. My name is Ben Manning. I am the lead data scientist at HashMap. I appreciate you guys watching. Be sure and subscribe to our YouTube channel to keep up with all of our weekly updates. Thanks so much, everyone.